Okay. I'm really excited to bring us to our final Full Stack Academy immersive project, following which I'm also very excited to watch the Grace Hopper projects, which I haven't seen yet. This final project takes everything that we've been talking about today in terms of platforms and technologies and learning processes and exploring protocols and meta projects. It marries it all into a very cohesive package. So without further ado, let's see this final project.
Hi, everyone. My name is Mike Peretz. This is Terry O'Toole, James Dehan, and Christine Dillon. And we're so excited to tell you today about our app, Parrot. Parrot is a desktop application built for remote pair programming. It combines peer-to-peer video, live code editing, and version control using Git and GitHub all into one seamless package. As you may know, pair programming has long been a standard in web development and engineering because it allows for deeper collaboration and thus ultimately produces higher quality code. But how do we implement pair programming into an organization whose workforce may span the globe? There are many individual tools and technologies that could help us with this, such as video chatting applications like Skype, screen sharing applications like Zoom, and many highly performant code sharing sites, but none that marry these three technologies together into one performant application, until now with Parrot. So without further ado, let's get started. Here is Terry to talk to you about our user experience.
Thanks, Mike. So let's say that Mike in New York and James in London have decided to pair program on their Juke Music Player app. All they need to do to get started is access the Parrot desktop app and log in using their GitHub credentials. Since we're hooked up into GitHub's API, we then have instant access to all of Mike's most recent repositories. And by selecting one, we're given an instant list of all of the current collaborators who are available to pair with. Once James is in the room, we can initiate a pair call, and this brings them to a web chat where they can decide who's the driver and who's the navigator in a typical pair programming paradigm. Once they're decided on that, they'll come into the text editor where the driver can locate the files on their local machine that correspond to the GitHub repo selected earlier. But they have to be sure to select the correct files, or else Parrot will warn them and ask to find the new ones. So here's Christine to dive deeper into the pairing experience.
Thanks, Terry. So today, Mike and James are working on the albums component of their application, and Parrot has three key features that help make that process really easy for them. The first is the video chat, which allows them to discuss their project face-to-face. Second is the shared text editor, which means that every action that the driver takes, such as opening files, editing files, toggling between tabs, closing files, happens instantly in real time on the navigator's screen. Finally, when they're done with their work for the day, they need to commit it to their repository on GitHub, and the built-in Git buttons makes that process easy for them. Each button corresponds to a commonly used Git workflow command, which means that the driver can add files to the staging area, check out a new branch, write a commit message, push it to the remote repository, all without leaving the application. They can also click the link at the top of the page to check out the remote repository, make a pull request, and merge it with the master branch. And now here's James to tell you about the technologies we use and some of the challenges that we faced.
Thank you, Christine. So, Parrot was built as a desktop app using Electron, and there are three core technologies that allow us to make Parrot a reality. Implementing the text editor component was a significant challenge. In order to do this, we used ACE, which is an embeddable code editor written in JavaScript. In order to have the displays truly mirror one another, every action taken by the driver must be communicated to the navigator via sockets. However, as we built a desktop app, we also had to build a remote server to facilitate this communication. In order to implement the web chat component, we used WebRTC. WebRTC is a peer-to-peer data sharing API built into most modern web browsers. We chose to do this without the use of the third-party library, which meant that we had to find a way to work with all implemented security features. In order to initialize a peer-to-peer connection with WebRTC, each of the users must send a request to a Google Stun server, which will return their public IP address. They then return these addresses and exchange them over sockets and use them to initiate the peer-to-peer connection. Once initiated, they can share media data across this connection, and the video chat begins. Choosing to build this as a native app was a far greater challenge than had we chose to build it as a web app, but also gave us a great advantage of being able to access the command line of the user's local machine in order to perform simple Git commands using JavaScript. I'll now pass you back to Mike, who will tell you how you compare it.
Thank you, James. Because of its combined collaborative technologies, Parrot is your best bet for pair programming with a friend or colleague who may not be in your same location. In fact, towards the end of our 2.5-week project period, we found ourselves using Parrot to finish up some of its final functionality and styling. We are extremely proud of Parrot, so we hope you'll check it out at our website, download it, and use it to pair with a friend or colleague. You can also find a link to our GitHub page and check out our code. Always remember, the next time you want to pair program, don't leave home. Just pair it.
All right, that was very cool. That was very cool. I like the GitHub integration. I think the Git integration. I think that's a problem that so many students have early on. That it's really cool that they got that integrated right into the application itself.